All right, today we are talking about the fourth section of this chapter and our third conic section. So far we've talked about parabolas and circles. Today we're talking about ellipses. Ellipses are related to circles because an ellipse is kind of like an oval. So it's kind of like a circle that's been stretched out in one direction. So we're going to write equations of ellipses and practice graphing them today. So there's a lot of vocabulary to look out for in this section. Make sure that as we're going through, you identify each of these things. Make sure you notice them on the diagrams and that you understand what they all are, because that's going to be key to your understanding of the problems, understanding what you're given, which means you need to understand what all of these things are. So sorry these pictures aren't super great, but an ellipse, you can see over here in these graphs, ellipses are basically ovals. They have a special property. An ellipse is the set of all points in the plane such that the sum of the distances from two fixed points is constant. Those 2 points are called the foci. So a parabola had one focus, an ellipse has 2. So if you look over here at this graph, here's one focus and here's another. The distance from the focus to any point on my ellipse, so let's say from here and from here, if I add those distances together, it will be the same everywhere. That's what it means to be an ellipse. Any point on my ellipse, if I measure the distance to both foci, I will get the same distance. So in our ellipse, we have 2 different axes. An ellipse is symmetrical, but not as symmetrical as a circle, right? A circle is the same everywhere. Every ellipse has 2 axes. It has a major axis, which is the longer axis, and a minor axis, which is the shorter axis. Those axes are perpendicular in the middle, and that middle is called the center of the ellipse. In both of these pictures, you can see that the center of the ellipse is at 0, 0. We'll talk about ellipses at 0, 0, and also moved left and right and up and down. The foci of an ellipse always lie on the major axis. So in this first picture up here, where my ellipse is kind of horizontal, the long way is horizontal, my foci are on the horizontal axis. That's my major axis. And here, when my ellipse is vertical, the foci are on the y-axis in this case, which is part of my major axis, the longer axis of the ellipse. The foci are always on the major axis. The endpoints of the major axis we call vertices of the ellipse. So we're used to thinking of vertices as corners. They're not really corners here. In these pictures, my vertices, for example, are here and here. We call those the vertices at the end of the major axis. If we look at our minor axis, we have what we call co-vertices. All right, so in the picture up here, my vertices are at negative a0 and a0 on the x-axis. My co-vertices are on my minor axis. So everything depends on the way that the ellipse is oriented. All right, here are the equations again. My goal is for you to be able to use these, so I will give you this table on your tests and quizzes. Standard form is x squared over a squared plus y squared over b squared equals 1. So in an ellipse, I'm always setting it equal to 1, and there's 2 fractions added together. This is for the horizontal orientation, so an ellipse that's sideways like this. The foci are at c0 and negative c0. We're going to see where we get c from in a minute. The length of the major axis is 2 times a, and the length of the minor axis, is 2 times b. C comes from this relationship that we're going to look at down here. If my ellipse is vertical, then I have y squared over a squared. So a always represents my major axis. So if my bigger number is under x, it's a horizontal ellipse. If my bigger number is under y, it's a vertical ellipse. So in this case, 2 times a is still my major axis, and 2 times b is still my minor axis. Notice that this time, though, the c is in the y position for the foci, because since it's vertical, my foci will be vertically oriented. So we have several important relationships. The length of the major axis, 2a, is the sum of the distances from the foci to any point on the ellipse. The values of a, b, and c, this is one we're going to use a lot, is related by this. C squared is equal always to a squared minus b squared. The distance from a focus to a co-vertex is a units, okay, which I think we saw back here. So you can see what they're showing you here. If I take the distance from a co-vertex to a focus, that's A, no matter which way it's oriented. The distance from a focus to a co-vertex is always A. And the sum of the distances from the foci to any point on the ellipse, which we call our constant sum, remember I said that always has to be the same, is larger than the distance between the foci. That's kind of obvious, because if the distance between my foci should always be less than any distance that I'm measuring from the foci to the edge of my ellipse, otherwise I wouldn't have an ellipse. Okay, that's a lot of time on vocabulary and things like that, but it's really important to understand that, so we'll get as far through the notes as we can. We're going to start, this is just a reminder, and I think I actually said this is just written out. In standard form, if my x term has the bigger number under it, it's horizontal. If the y term has the bigger number under it, the bigger denominator, then my ellipse is vertical. All right, so we're going to start by writing an equation for this ellipse. Here we're given a vertical ellipse, so that means my major axis goes from 0, 5 to 0, negative 5, and my minor axis is horizontal. So first I need to find the center. Pretty easy to see in this one. It's halfway between the foci. So here my center is 0, 0. And now we need to find the value of A. We know that the major axis is 2 times A. So how long is my major axis? Well, it goes from 0, 5 to 0, negative 5. So my major axis is 10 units long. That means that A equals 5, because my major axis is 2 times A, so A is 5. The distance from the center to the vertex is 5. That means my major axis is 10 units long. Here they're showing you how to do that. All right, keep looking at your graph that you have on your paper. I need to find the value of B. I need to use my relationship between A, B, and C to find that, because I know that A is 5, and I know that C is 4. Remember that C is the distance from the focus to the center. So this is the point 0, C, and this is the point 0, negative C. So C is 4 if you look back at your chart. So we're going to use that relationship that we said between C squared, A squared, and B squared, this relationship, to solve for B. So we know that C is 4, so C squared is 16. We know A is 5, so A squared is 25, and then I just need to solve for B squared, and I end up with 3. But actually for my equation, I only need to know that B squared is 9, right? Because what goes in my denominator, remember this is the general form, standard form. My major axis needs to go underneath Y because it's a vertically aligned ellipse. So this would be the equation of my ellipse. Y squared over 25 plus x squared over 9 equals 1. All right, so check your progress with this one. In this case, A should be your result. This is a vertical ellipse, so what needs to go here under y squared is A squared. Again, we notice the distance from the vertex to the center is 5 units. That equals A. And then I know that my C value here is 3. So I use the C squared equals A squared minus B squared. So I get 9 equals 25 minus B squared. That's B squared equals 16. So B equals 4, but what I need to put under my x is my B squared. All right, let's just remind ourselves how translations and transformations work. So here, my center, instead of being at 0, 0, is at H. Okay. So it's going to work exactly the same as a circle. X minus H quantity squared, Y minus K quantity squared. The difference is that I'm dividing by my A squared and my B squared, right? So horizontally, that H is going to affect my foci. It's going to move the X value of my foci left and right. It's going to move the X value of my vertices left or right. And it's going to move the Y value of my co-vertices up and down. It's the opposite with a vertical ellipse, right? So notice here the K has to go with Y and the H with X. This is a vertical ellipse, so it's going to change the Y value of my foci, the Y value of my vertices, and the X values of my co-vertices. So here we're going to write an equation for an ellipse when we're given the lengths of the axes, okay? So here we have an equation for an ellipse that has vertices at -6, -2, and 4, -2. and co-vertices at -1, -4, and -1, 0. It usually helps me to just kind of sketch myself a little coordinate plane and figure out where the points would go. So that's what I did here. A pretty terrible sketch, but I'm looking at my vertices being here at -6, -2, and 4, -2. So I know this is going to be a horizontal ellipse. My co-vertices are at -1, -4, and -1, 0. So that just kind of helps me visualize. I need to find the center of my ellipse, which is halfway between my vertices. So here, they're just showing you the midpoint formula to go halfway between my two vertices. Remember, the vertices, halfway between them is the center. So my center is -1, -2. The length of the major axis then, which is between my two vertices, is 10 units, right? From -6, -2 to 4, -2 is 10 units. That means that my A value is 5, half of the major axis. Okay, the length of the minor axis is 4. That means B is 2. Remember, B is half the length of the minor axis. So this would be the equation of my ellipse. This is x minus -1, because remember my center is at -1, -2. And this is y minus -2, quantity squared. Since this is a horizontal ellipse, my major axis number goes here. So half the major axis is 5. 5 squared is 25. My minor axis, half of that is 2. 2 squared is 4. So this would be my equation. Okay, you guys try this one. The answer for this one is C, and I will show you how to get that. All right, so I tried to draw a slightly more beautiful graph than last time. Here are my vertices at -9, 1, and 1, 1. So halfway between those is the center. You can see I did that here with the midpoint formula. So my center is -4, +1. The distance between my vertices is the length of my major axis, which is 10 units. That means that A is half of that, so A is 5. So A squared is 25, right? The length of my minor axis is 6 units. So B equals 3, half of that. That means B squared is 9. So I can see in C that B squared is 9 and A squared 25. Here I have a center with -4, +1, because remember the minus comes from the formula. So this is really x minus -4 quantity squared and y minus 1 quantity squared. Okay, we're going to try to do one more example here. Skip ahead to example 4 because I want to remind us how to complete the square. It's asking for the coordinates of the center and the foci and the lengths of the major and minor axes of this ellipse. This ellipse is not in standard form. I need to complete the square like we've been doing in the last two sections to put it in standard form. So notice I gather my x terms together and I gather my y terms together. Remember to complete the square, I factor out whatever the leading coefficient of my y is so that this leaves me with 1y. So what do I need to add here? I'm going to add a 9 for the x. And inside my parentheses, half of -4 is -2 squared is 4. So I'm going to add a 4 here. But it's really a 16, right? Because it's 4 times 4. So on this side, I need to add a 9. And I need to add 4 times 4, or 16, just like we've been doing. That gives me this beautiful situation. Here they're just showing us how we got the numbers we added. So this becomes x minus 3 quantity squared. And this part becomes y minus 2 quantity squared. And when I simplify the right-hand side, I get 36. And then because ellipses always have to be equal to 1, I'm dividing everything by 36 to make this equal to 1. So that gives me x minus 3 quantity squared over 36 plus 4 over 36 divides out to 1 over 9. So that's where they get the 9 here. And then 36 over 36 is 1. So this is the standard form of my ellipse. So what are the questions they asked me? Well, I need to know the center. So my center is going to be +3, +2. A squared is 36, which means that A has to equal 6. B squared is 9, which means that B is 3. I need to find my C value because it asks about the foci. So remember this relationship, C squared equals A squared minus B squared. So C squared is 36 minus 9, which is 27. That means that C is the square root of 27, which they simplified here to 3 square root of 3. So the center is at 3, 2. The length of the major axis is 2 times A, which is 12. The length of the minor axis is 2 times B, which is 6. And these are the coordinates of my foci, because this is a horizontal ellipse. so that h value of my vertex changes the x value of my foci. And here's our last check your progress. Your answer here should be C.